Alright, testing. No, we're not testing. We're just working some problems. Never mind. We're here at gotomath.com. Let's click on the calculus. And what are we doing now? Ooh, we just got through doing that definite integral section by the... Oh my gosh. Glad that's over. Fundamental theorem of calculus. Let's do it. Alright. Now, it says use the fundamental theorem of calculus to find the definite integral. Definite means, I guess it's defined. It's been defined on an interval. It says use the fundamental theorem of calculus to find the definite integral. Okay. Let's write that down. 1 to 14, 10 dx. Everybody got that? Do you have that? Let me write that down or I'll forget it. 1 to 14, 10 dx. Just a dx. Let's move over. Let's figure out how do we figure this out. Now, in a previous section, we used the definition. And to do that, but we don't want to do that every time, or we're going to be spending the rest of our life solving a couple problems. So this thing here, which looks like a big S, the integral symbol, these are our limits, 1 to 14, our function f of x equal to 10, and dx. Now, this part in here is called the integrand. We give this the integrand. These is like a lower limit, upper limit. You can kind of look at this sometimes as the area under the curve. Now, if we're to graph, let's say, okay, our function is f of x here is equal to 10, and if this would just be a horizontal line, passes through, let's say, 10 here on the y-axis, and if we were to let's say, let that be 1, and okay, so this is not to scale, and this is 14 here. You could look at this as this is going to be equal to, let's say, the area of this box, right? So you would take the difference here, 14 minus 1, and then multiply it by the height, which is 10, right? And anyway, that gives you the area of the box. Well, really, that's what's going on here. But we don't really say this every time because this curve could be down here below the x-axis and we end up getting a negative number and whatever. Alright, so this integral symbol right here, which kind of looks like an S, and you could think of it as an S for sum. We're summing up a bunch of rectangles, and we kind of talked about that in the previous section, but we didn't really get into it too much. But anyway, let me go ahead and just go ahead and state something here on the fundamental theorem of calculus, okay? And we're going to let f be, and normally I don't do this, a continuous function, so we'll consider it to be a continuous function. Continuous function. Yeah, normally I don't do a whole lot of writing. It's kind of difficult to write on this thing I've got. Continuous function on a closed interval. So the closed interval we'll say is a, that's supposed to be an a, b on a closed interval ab, so this would be like your a and this is your b there, okay? And f, that's capital F, alright, capital F is an anti-Christ, no, just kidding, the antiderivative. Is the do we remember know what the antiderivative is? The antiderivative of f, right? That's little f, that's this f here, okay? So when we did indefinite integration, I think we mentioned the antiderivative. And f is an antiderivative of f on, it's on, I'm trying to remember this, on the interval, on the interval AB, so the same interval, right? on the interval AB. Then, so I say let f be a continuous, if f is a continuous function on the closed interval AB and f is an antiderivative of f on the interval AB, then from A to B, right, there's our little f of x dx is equal to capital F of B minus f of A. And you've seen this f here. We would say this is equal to capital F of x over here when we did indefinite integration. Right. So there it is. That's all there is to the fundamental theorem of calculus, right? So this is the fundamental theorem. I'm not going to write it out. Anyway, the fundamental theorem of calculus, you hear me. So there it is. That's all we got to do. That's it. So, in other words, we need to find what f is, right? Find f of x, really. On this thing, you could say this is f of equal to f of x, right? F of b minus f of a. Well, I guess that's not really true, is it? That's if we didn't have these bounds here. Yeah. Anyway, let's cancel that out. Okay, let's stick with this here. So you know how to find the integral. You should know how to find. I guess I'm going to scroll up the screen here. You should know how to find the integral of 10 dx. Okay, this was in the indefinite integral section. So that's 10x plus the constant. And so remember, f of x, this was the antiderivative, 10x plus c, 10x plus c, okay? And however, we're on this interval between, what was it, 1 and 14? 1 and 14. We're on this interval between 1 and 14. And so you're saying f of 14 minus f of 1. F of 14 minus f of 1. So if we were to actually use this, okay, then you would just plug 14 in. So this would be 10 times 14. Now, you know something? What's going to happen here is, I'm going to say plus c here, okay? And then you go minus, and then always start a parentheses. Then you have 10 times 1 minus c, right? Because both these numbers are the same number. What happens is we distribute this negative across, okay? The c's end up canceling out. The c's end up canceling out. And so we end up with 10 times 14 minus 10 times 1. And that's 140 minus 10 is 130. Is that what I'm getting? Here, 130. However, when we do it like this, I'm going to write 1 and 14 here. Alright, we got some different kind of notation. Okay, so this becomes 10x, and of course that's this part here. But we don't write plus c, we just do this bar thing here and say 1 and 14. Okay, and then we go ahead, plug 14 in. 10 times 14 minus, and then 10 times 1. I guess I did. Well, I needed to put a parentheses here showing you that when I distribute this negative across, it becomes a plus c. Or, what the heck? I don't know why I wrote a minus there. I was getting ahead of myself. Distribute it across, then it becomes a minus c, and the c's cancel out. Okay, I wish somebody would have stopped me on that. So there you go. Okay, if you've never seen this before, it's no big deal. I promise. Powerful stuff, believe it or not. What did I say, 130? Let's click the answer and hope that's it, 130, okay? So you want to practice that, all right? Some of these other problems, I'm not going to go into detail like I did in this one. All right, as much detail, it's just the way I do, man. It's the way I roll, baby. All right, it's 9:58. Let's do it. Let's do a new one. Anyway, let me finish this off. So come on back to gotomath.com, check it out. Maybe I'll see you there. Bye.